let's dive into another Mtel question. This one says, triangle ABC is a right triangle with hypotenuse AB. So let's start there. Let's draw that triangle. So there's our triangle ABC. And they're telling us segment MN is drawn parallel to side AC with M on hypotenuse AB and N on side CB. So let's draw that in as well. So it sounds like the line looks something like that, parallel to AC. And M is the point that lies on the hypotenuse, so that would be the point right there. And N would be down here on side CB. And they're telling us that AC equals 20, CN equals 12, so it looks like my picture is not to scale, but that 12 would go right there. And MN also equals 12. So that little piece equals 12 as well. So they're asking, what is the length of side CB? Okay, so this is looking like a similar triangles problem to me. So we've got a larger triangle ABC and then a smaller triangle MNB. And all of these triangles have all of the same angles because of these parallel lines. So we know that this angle is the same as this angle. This angle is going to be the same as itself. We know that these angles are right angles because these two lines are parallel, and they told us that ABC is a right triangle. And then we know that B is going to be the same as itself. And if you know all of the angles in two different triangles are the same, then they are similar triangles by definition. So we can use ratios to figure out how the sides relate to each other. So with these triangles, we know that AC and MN correspond, meaning they're the same side in the two similar triangles. Like they represent the same side because of where the angles lie. So using the rules for similar triangles, we can create a ratio with this information. So the ratio of MN to AC should be 12 to 20, and that ratio should be the same as any other two corresponding sides. Well, we're looking for CB, and CB is in the same triangle as AC. So we should put that on the bottom of our ratio. We should put CB on the bottom of our ratio. So I'm going to set this up like CB on the bottom, and on top should be NB, because NB is the corresponding side in the smaller triangle. In MNB, side NB is in the same place as side CB. So hopefully that makes sense. We have these two similar triangles. MN and AC are in the same place in those triangles. Those are corresponding sides. That's why I'm giving it 12 over 20. And that ratio of those two sides should equal the other two sets of corresponding sides. So NB over CB is something that we can use. We're looking for CB, so we have to figure out some way, set up a ratio that we're going to be able to solve to make this work. Well, if we label NB as our x, then we can do just that. We can put x's into our equation. So now NB in our equation is going to become x. And then CB we can represent as 12 plus x, because you can see that a piece of this is 12 and then the other piece is x. So if we add those together, we get CB. Sweet. So now we've got an equation that only has one variable. X is our only variable. So all we have to do here is solve this equation. So I can cross multiply here and get rid of these fractions. So I can do 12 times 12 plus x, and that's going to equal 20 times x. If I multiply bottom left to the top right and the bottom right to the top left, that's cross multiplying. And we can distribute this 12 through. We get 144, that's 12 times 12, plus 12x. That's going to equal 20x. Solving this equation, we can subtract the 12x over to the other side, so we get 144 equals now 8x. And 144 divided by 8 is our last step here, which is 18. So 18 equals x, but we're not wondering what x is, we're wondering what CB is. X was NB, so to find CB we have to do 18 plus 12, which is 30, giving us answer D.